Redox. Is corrosion your problem? Oxidation. Oxidation is all around us. Oxidation is defined as the interaction between oxygen molecules and all the different substances that may get in contact from metal to living tissue. Today's definition is a little bit different and is the loss of at least one electron when two or more substances interact. Those substances may or may not include oxygen. Reduction. As we have north and south, arrive and depart, curly and straight, up and down, bad and evil, young and old. Reduction is actually the opposite of oxidation. Is the addition of at least one electron when substances come in contact with each other. So oxidation and reduction, there are processes that happen simultaneously. Let's analyze the process. We have a substance that will lose an electron through oxidation, and a substance that will gain an electron by reduction. In order to remember this easily, let's learn this acronym, LEO-GER. LEO is for lose electrons oxidation, and GER, gain electrons reduction. In here we can see a compound A is being oxidized, losing electrons, and that's what we call the reducing agent. A compound B is being reduced by gaining electrons and is what is called oxidizing agent. This is the same as when electrons are gained, the oxidation number decreases. When the electrons are lost, oxidation number increases. Corrosion is a natural tendency of materials to return to their most thermodynamically stable state. This process is usually deteriorative to materials. Iron metal, for example, is mined and by human processes can turn into a fence. But later on, by thermodynamical stable states, it will be looked for and iron will try to return to the natural form. Now, corrosion can be controlled to prevent this deterioration in three general ways. 1. By control the environment. This is putting things away from the environment. 2. By design the materials. The shape of the materials helps the environment not to be that much in contact with the object. And 3. Design a barrier between the materials and the environment. The material will prevent the environment from damaging the object. Not all metals have the same activity to corrosion, and here is a table of corrosion activity. In here we can see, for example, magnesium, zinc, and aluminum are the most active, whereas in this table gold, stainless steel, and bronze are least active. Rust is a form of corrosion that is specific to iron. Iron oxide is rust, so any other metal can rust, only iron. Now, how do we get to specify an oxidation number? Let's follow these rules. Rule number 1. Oxidation number of monatomic ions is equal to the charge and magnitude of the ionic charge. For example, bromide, that is -1, the oxidation number will be -1. Rule number 2. Oxidation number of hydrogen in a compound is always +1, except with metal compounds where hydrogen oxidation number is -1. So, if we have hydrobromic acid, the hydrogen oxidation number will be +1. But if we have sodium hydride, hydrogen will get the oxidation number of -1. Oxidation number of oxygen in a compound is always negative 2, except with peroxidase, where we have H2O2, where it's negative 1. Oxidation number of an atom in uncombined form is always 0. That is, if we have magnesium or bromide alone, the oxidation number will be 0. Rule number 5. For any neutral compound, the sum of oxidation numbers of the atoms is always 0. So if we have sodium bromide, the addition of oxidation numbers will be 0. Rule number 6. For polyatomic ions, the sum of the oxidation numbers must equal the ionic charge of the ion. An example, if we have hydroxide, oxidation number of oxygen will be negative 1 and hydrogen is positive 1. So the addition will give us negative 1. That is the ion charge of hydroxide. Now is your time. Determine the oxidation number of each element in the following compounds. Stop the video, and when you are done, play it back so you can compare your answers. Good luck! Now, it's time to put things together. You know about oxidation numbers. And also, we know that when the oxidation number increases, that is what we call oxidation. When the oxidation number decreases, this is what we call reduction. So, it's time to put these to work, and let's find out which elements are being oxidized and which one are being reduced. In here, we can see the oxidation numbers of copper and oxygen and magnesium. As we can see, magnesium is jumping from 0 to positive 2. So, as the oxidation number is increasing, it's being oxidized. Whereas copper, from positive 2 to 0, is being reduced because it's decreasing. Because of this, magnesium will be the reducing agent, and copper will be the oxidating agent. Now is your time. Identify which atoms are oxidized and which are reduced, as well as oxidizing agent and reducing agent in the following reactions. Stop the video, and when you are done, play it back so you can compare your answers. Good luck! Thank you for watching.